We are talking about network analysis. Please confirm that the screen is visible. Please confirm that our screen is visible. Please confirm that our screen is visible. So network analysis is yet another technique. Another technique that is used in management or by managers to aid project contracts or projects for that matter, especially in understanding the duration of the project, the cost of the project, and the resource requirements. The main output of this process is the network diagram, which is like a map showing how the project is going to be conducted, how the activities are related. So network analysis refers to a family of related techniques developed to aid management to plan and control projects. We are saying that network analysis is used to evaluate projects that are large and complex, where restrictions in terms of time and resources exist. So why project planning? Why network analysis? Under the importance of network analysis, number one, we are saying that at the planning stage, network analysis helps managers to plan on how to get started on the project by identifying the activities of the project. So as you're planning anything that you need to start on, you need to plan. So this technique helps us in getting to know how to get started on the project and also identifying the activities of the project. Network analysis, again, helps in showing the interrelationship of various jobs or tasks which make up the overall project and identifying the time durations of each interrelationship, how the different projects are related. Network analysis clearly identifies the critical parts of the project. It provides planning and control of information, cost, and resource aspects of the project. Provides planning, control of information on time, cost, and resource aspects of the project. Network analysis helps in determining the total completion time to the project if everything goes as to the plan. Okay, total completion time. Network analysis helps in determining the total completion time to the project. So we are able to tell whether the project will take us 1 month or 1 year or 1 week and so on. So that is output of the process. So it is a very powerful tool, but I can just list 3 things. One is completion, which is project duration. Cost, which is the project expenditure. And then the resources, which is the personnel and equipment, or manpower for that matter. Completion, cost, resources. Completion, cost, sources. So this is what this tool helps us. So it's a very, very powerful tool out there for managers that are looking at these projects. Now, the main output of the process is the network diagram, which shows the activities and events within the project. One of the major components of this network diagram are the activities, which are denoted or represented by a forward moving arrow. This is a forward moving arrow, and I call it such because it is indeed a forward moving arrow. It is moving forwards. And the activity is a task or job of work which consumes our time and resources. It consumes our time and resources. Then we have the event. The event is a point in time, and this indicates the start or finish of an activity or activities. The event is represented by a circle in the network. So we shall be having those circles in our network. At the beginning of every activity and the network or project itself, we shall have that circle. Then we shall insert some dummy activities, which are just for compliance, ensuring that we do the right thing when it comes to the preparation of the network diagrams. So the activity is it is a task which does not consume time or resources and is used merely to show clearly the logical dependencies between activities so as not to violate the rules for drawing networks. This one is represented on our network diagram by dotted arrows. This one here, the dotted arrow. Okay, so we have the rules of drawing networks. Rules of drawing networks. Number 1, a complete network should have only one point of entry, which is the start event, and only one point of exit, which is the finish event. We always begin with a circle, end with a circle, and ensure that all the activities, the forward moving arrows, are confined within the circles. Next, every activity must have one preceding or tail event and one succeeding or head event. Several activities may use the same tail event and head event. No activity can start until its tail event is reached. An event is not complete until all activities leading into it are complete. Loops are not allowed. We shall be seeing that. All activities must be tied into our network. Networks proceed from left to right, and networks are not drawn to scale. The length of the arrow does not represent the time elapsed. The arrows don't represent the time elapsed. Okay, so before we do anything, we are just going to draw a basic network diagram. A basic network diagram. Which I'm picking from November 2018. November 2018, question 6, part B. We are going to put down this in the next 3 minutes. Please confirm November 2018 is on your screens. November 2018. Please confirm on your screen that this is visible. All right, let us proceed. Let us proceed with let us proceed with putting down this. So in the required, we are going to draw an activity network. We shall list the possible paths within the network and their duration. We shall identify the critical path and justify our answer. So these are the parts that we are going to focus on. So as I've mentioned, we always have a start event and the end event. We always have a start event and end event. These signal the beginning and the end of the project. So get your books, draw as I'm drawing mine here. Now, according to the question, we have, let me just take you back a little bit. We have the activity itself and the preceding activity. We have preceding and the activity. So preceding, this one must be completed. These activities must be completed before we start on these ones here. A preceding activity must be completed before you start on the main activity. For instance, as you can see, activity A does not have a preceding. Activity A does not have preceding. So you can already start with activity A. Then activity B and C can only be started on if activity A has been completed. You can only start on activity B and C if activity A is completed. You see that? Then we have activity D. Activity D must be started on after C is completed. So you can never start on D unless C is completed. Activity E will be started on after we have completed B. Activity F must be started on after we've completed D. So these ones must be completed before we start on. So that shows the interrelationship between the activities. That shows the interrelationship between the activities. So according to this, we must begin on activity A because activity A does not wait because it doesn't have a preceding activity. It doesn't wait. Then after activity A, we shall have another circle to represent the end. Then from there, we begin on B and C. Why? Because when you look at your table, you will see that when we finish activity A, we start on activity B and C. Then we have another circle on the head of B and another circle on the head of C. And then after that, we have activity D coming out of C because activity C precedes activity D, meaning that activity D must be completed before C is started on. I mean, activity C must be completed before D is started on. Sorry about that. Then here we have another circle to show the end of D. And then you can see there is another arrow coming out of that path where we have A, B, and where we have B, we have that arrow coming out, and that is activity E. We are told in the table that activity E can only be started on after B is done. So when we finish B, we start on E. And after D, we start on activity F. After D, we start on activity F. Why is E and F pointing in the same direction? Who can tell me in the chat? Why is E and F pointing on the same circle? Why is E and F pointing to the same circle? What's the reason? Talk to me in the chat. Talk to me. Show me that you are alert. Anybody? Same preceding activity. Perfect. Kokasi says in the chat, you can read there in the chat, E and F, they have the same preceding. I mean, they're the preceding activities of G. They are the preceding activities of G. Because we can never start on G until E and F are done. We can never start on G until E and F are done. They result into G. Yes, they result into G. They result into G. So here we are. We have our complete network. So activity A takes us 6 days. Activity B takes us 8 days. Activity C takes us 7 days. Activity A takes us, D takes us 12 days. E takes us 3 days. F takes us 5 days. G takes us 7 days. So let us draw our network. Notify me in the chat when you're done. We continue. So you can share with me the path within the network. Share with me. We have path A, B, E, F, A, B, E, G, and S, C, D, F, G. Okay. We have path, good. We have path A, B, G, and path A, C, D, F, G. Now, when we look at the number of days, we see that path 1 is for 24 days, and path 2 is for 37 days, because we are looking at, for path 1, we are looking at 6 days on path A, on activity A, 8 days on B, 3 days on E, 7 days on G. Then path number 2, we have SC, DFG, 6 days on A, 7 days on C, 12 days on D, 5 days on F, 7 days on G. Those are 37 days. Okay, now, according to the definition of the critical path, let me just clean up this one. So I wanted to, let me first get this definition. I want to clean up this. The definition of critical path is up here. The critical path is the path with the longest duration, 37 days, or the path with the shortest time in which the project can be completed. The critical path is the path with the longest duration of 37 days, or the path with the shortest time in which the project can be completed. So it means that the critical path is a path SC, let me put it in red, SC, D, F, G. That one there is our critical path, the one in red. The path with, okay, let me just simplify this. The path with the longest duration. Path with longest duration. And those are the 37 days. The path with the longest duration. Now, you should note that the critical path gives us the project duration. So it means that the duration of the project, is equal to 37 days. Duration of the project is 37 days. 37 days. That's the duration of the project.